Hello and welcome to another episode of Math with Mrs. Wilson. This is section 9.3, the quadratic formula. And in this section, you'll be able to derive the quadratic formula, solve quadratic equations using the quadratic formula, and use the discriminant to predict the number and type of solutions of a quadratic equation. Let's start with deriving the quadratic formula. We begin with the quadratic equation in standard form, where a, b, and c are constants, and x squared and x are the variables. So the first step is to isolate the variable terms on one side. So that means we're going to leave the ax squared and the bx on the left side, but we're going to subtract c so that it moves over to the right side. Next, it says we're going to make the coefficient of x squared equal to 1 by dividing by a. So everything is going to get divided by a. Remember, a is a constant, so it's just a number that we're dividing by. To simplify this, now we just have x squared plus bx over a and negative c over a. So you can see that we just simplified it by canceling out the a's on the first term. Now we are deriving the quadratic equation or the quadratic formula from what we know about completing the square. So we need to take that term, the b over a, which is part of the x, right, or it's the coefficient of x, and we are going to multiply it by half and square it. So when we do that, we get b over 2a squared, which is equal to b squared over 4a squared. Now, it's asking us to add that to both sides. So if we add it to both sides, it doesn't change the equation. So we have x squared plus bx over a, and then we're adding the b squared over 4a squared to both sides. Negative c over a, and then we have to add the b squared to this side over 4a squared. So we're just manipulating this equation around until we get just x by itself. And to do that, we had to complete the square, because that's how we solve when we're solving for x. The next step says that the left side is a perfect square, so we want to factor it. And when we're completing the square, it's usually this piece that helps us factor it into a perfect square trinomial. So we get x plus that b over 2a. And if we were to expand this and FOIL it, we would get this piece. If you don't believe me, you can pause the video and FOIL it out and see that you end up with the piece that's above. So that is just equal bringing down the right side of the equation. The next step says to find the common denominator of the right side and right equivalent fractions with the common denominator. So that means we're not doing anything to the left side, just bring it down. The right side, the denominators are a and 4a squared. Let's just put the b squared 4a squared on the left side, and then minus c over a. The common denominator is going to be 4a squared. So we're going to multiply this by 4a in the numerator and denominator. We'll simplify that. So again, the left side of the equation remains the same. Just bring it down. And then bring down this piece, b squared over 4a squared, minus, then we have 4ac over 4a squared. The next step is telling us to combine it as one fraction. Just copying down the left side again. The right side combines into one fraction. the next step, it says to use the square root property. So remember, the whole point of this is to get it to the point where it's just x equals, so that we can use this formula for any quadratic. So when we use the square root property, the left side, the square goes away, and then we have to take the square root of everything on the right side. So b squared minus 4ac over 4a squared. The next step asks us to simplify the radical. So we have x plus b over 2a, oops, I forgot my plus or minus, is equal to plus or minus. In the denominator simplifies to just 2a, because the square root of 4a squared is 2a. So in the numerator, we have b squared minus 4ac under the radical still, because we can't simplify that. The next step says to add a negative b over 2a to both sides. So x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And the very last step, so we already have it as x equals, which is completely fine, but we can simplify it a little bit further to this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is the quadratic formula. And you just derived it. For some of you, you'll be able to do this again and repeat these steps. If you're advanced, I think that is a really important thing for you to be able to do, to drive these steps, because it lends itself to proofs when we get into geometry, being able to prove something. When you're ready, turn the page. So here again is the quadratic formula, and I have a song to help you remember it, and it's to the tune of Pop Goes the Weasel. It goes like this: x equals negative b plus or minus square root b squared minus 4ac all over 2a. And you can pause it and try to sing it along with just looking at the formula. It's important that you memorize this formula because you're going to be using it a lot. So a is the coefficient of the number that is beside the x squared. B is the coefficient that's in front of the number, or the number next to x. And then c is just the constant term at the end. All right, so looking at this next problem, we have 3 is our a, negative 5 is our b, and 2 is our c. So we're going to write that. A is 3, b is negative 5, c is 2. So to help you memorize the quadratic formula, you need to write it again. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now it's just a game of evaluating. So we're going to plug in to the quadratic formula. X equals negative b, which is going to be a negative 5, plus or minus the square root b squared, so negative 5 squared, minus 4, a is 3, c is 2, all over 2a, and a is 3. From here, you're going to want to, just color code these, you're going to want to simplify this. So notice how the a, b's, and c's get plugged in here to the quadratic, or to the quadratic formula. Now let's simplify this. So x is equal to, the negative 5 changes to just positive 5, plus or minus the square root. Negative 5 squared is 25. Negative 4 times 3 is negative 12, and negative 12 times 2 is negative 24, all over 2 times 3, which is 6. I'm just going to move our quadratic formula. It's a little squished for me. Every time you do a problem, you should write that out so that you can memorize it. So x is equal to 5 plus or minus 25 minus 24 is 1. The square root of 1 is 1, all over 6. So simplified further into our two solutions, we have 5 plus 1 over 6, which is just equal to 1, and 5 minus 1, which is 4, over 6, which is equal to 2/3. So these are our two solutions, the 1 and the 2/3. All right, I'm going to let you get up and go to the boards and do the try it. So you can check your answer here, x equals 1 and x equals negative 3/2. Now let's solve by using the quadratic formula on this one, where the coefficient, so the a, is 1. So you don't really see it, but it's in front of the x squared. Your b is negative 2, and your c, it's on the other side, so we have to bring it over. So you should rewrite this as x squared minus 2x minus 15 equals 0. So everything needs to be on the left side and equal to 0. Negative 15. From here, remember our quadratic formula, so practice it. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And then we're going to plug into there. So x equals negative b, which is negative 2, plus or minus the square root b squared, so negative 2 squared, minus 4a, which is 1, c is negative 15, all over 2a, which is 2 times 1. Let's simplify that. So x equals 4 plus or minus the square root of negative 2 squared is 4. Oh, I'm sorry, this first term is negative 2, which is just 2. Got ahead of myself. And 4 times 1 is 4, times 15 is 60, and it's a negative times a negative, so it's plus 60, all over 2. So the square root of 64 is going to be 8. So that is x equals 2 plus or minus 8 over 2. 2 plus 8 is 10. 10 divided by 2 is 5. So x equals 5. 2 minus 8 is negative 6. Negative 6 divided by 2 is negative 3. So these are our two solutions. All right. Remember on this try it that you need to bring the negative 10b to the other side, and we'll go over it and then come back. Check your answer, and when you're ready, turn the page. I think on your copy you may be missing this little square, like the 2 didn't get squared and so it's still a big 2 on yours, but it is supposed to be squared. So let's do a couple of these problems and then you can do the try-its. Alright, in this case, A is equal to 3, B is equal to 12, and C is equal to 7. X equals negative b plus or minus square root b squared minus 4ac all over 2a. and then we'll simplify that. So x equals negative 12 plus or minus the square root. 12 squared is 144. 12 times 7 is 84, all over 6. So 144 take away 84 is 80. So then we get x is equal to negative 12 over 6. I'm going to split it in this case, plus or minus the square root of 80 over 6. So that way we can simplify it. I think I subtracted these wrong. Let me just double check. 144 minus 84 is 60. I'm sorry, not 80. I thought I had that incorrect. 144 minus 84 is 60. And we can simplify this. Didn't leave much space. So x is equal to negative 2 plus or minus the square root of 60 is 4 times 15, so 4 comes out as a 2 and 15 stays in. And then it's over 6, which still simplifies further, so x equals negative 2 plus or minus the square root of 15 over 3. And we'll just leave it as that one solution for now, since we don't have much space. So that is 2 solutions if you were to put that into a calculator, but we'll just leave it, instead of saying negative 2 plus square root 15 over 3 and negative 2 minus square root of 15 over 3, we're just going to leave that since I didn't leave a lot of space. All right, and we'll save this try it for later. Let's do this one down here. 4a squared, so a is equal to 4, b is equal to negative 2, and c is equal to 8. X equals negative b, so that's going to actually be positive 2, plus or minus the square root, b squared, so negative 2 squared, that's just going to be 4, minus 4a, which is 4, c, which is 8, all over 2a, so 2 times 4 is 8. I'm going to simplify this. X is equal to, I'm just going to put it as 1/4. So 2 over 8 is 1/4, plus or minus the square root. This is still over 8. Oh, 4 times 4 is 16, and 16 times 8 is 128. So it's going to be 4 minus 128, which is going to give us a negative number. So x is equal to 1/4 plus or minus the square root of negative 128. Oh no, I'm sorry, 124 over 8. I'm going to simplify this with an I. So x is equal to 1/4 plus or minus the square root of 124i over 8. I'm sorry, that I does not go in the square root. Just put it outside the fraction. And 124 is divisible by 4. So a 4 can come out. X equals 1/4 plus or minus 4, and inside stays 31. And if you take the square root of 4, you actually get 2. Over 8i. The 2 over 8 can still simplify further, so x equals 1/4 plus or minus root 31 over 4i. And again, you could write that as two separate solutions, but we'll just leave it as the plus and minus for now since we don't have a lot of space. All right. These were kind of special forms of where we ended up with either a radical in our solution. In this case, we had a radical in our solution, and then we ended up with a complex number as a solution. So keep that into account that your answers can look like this while you are working on these two try-it problems. And when you're finished, we'll come back. Go ahead and check your work, and then we have a few more examples to cover. In this next one, we have to distribute and then write it into standard form because it is a quadratic, but it doesn't look like it right now. So we get 3y squared minus 6y when we distribute minus 3 equals 0. And now it's in standard form, and we can use the quadratic equation. But first, I might want to divide everything by 3. That would make it a lot easier. So we just get y squared minus 2y minus 1 equals 0. In this case, we're not solving for x, so I'm just going to move this over to here, just to give us some extra space. We're solving for y, so y equals, and so normally we would say x equals negative b, but in this case it's going to be a positive 2, because it's a negative negative, plus or minus square root b squared minus 4ac all over 2a, which is just 2 because 2 times 1. So this is 4 minus 4, which is 0. And the square root of 0 is 0. So it's just y equals 2 plus or minus 0 over 2. But 2 plus 0 is 2, and 2 minus 0 is 2. So in both cases, we get a 1. So we only have this one real solution, which is 1. When you have fractions, it's helpful if you can use the least common denominator and you multiply that out so that everything goes away. Think about what the least common denominator would be for 9, 2, and 3. Yeah, it's 18. So what I'm going to do is multiply both sides of the equation by 18. 18 times 1/9 is 18 ninths. And 18 times negative 1/2 is negative 18 over 2x. And then on the other side, we would have negative 18 over 3. The reason we multiply by 18 on both sides is because that least common denominator makes everything else cancel. So 18 over 9 becomes 2x squared minus 9x is equal to negative 6. Now we have to write this in standard form. So 2x squared minus 9x plus 6 equals 0. From here, we need to plug that into the quadratic formula. So x equals negative b, which is, it's going to be positive 9, plus or minus square root b squared, 81, b squared minus 4a, which is 2, c, which is 6, all over 2 times 2. All right. X is equal to 9 plus or minus, let's see, 4 times 2 is 8, times 6 is 48. 81 minus 48 is 33. And that's not going to be simplifiable, so just write that as 9/4 plus or minus the square root of 33/4. So really, it's all about plugging into the quadratic formula and then simplifying it. We have one more concept to cover called the discriminant. So remember how in this problem above, we had only one solution. The reason that was true was because in here, we ended up with the square root of 0. So we call the inside, this b squared minus 4ac, the inside the square root, the discriminant. And if the discriminant is greater than 0, you can see this in our little graphic organizer. If the discriminant is greater than 0, there's two real solutions. If it is equal to 0, there is one solution. And if it's less than 0, then there are no real solutions. And so that would be like this example up here. I'll highlight it over in pink again. Because we had a negative in our square root right here. That caused us to have no real solutions. We only had an imaginary solution. So let's look at A. If it's 8m squared minus 3m plus 6, our B is negative 3 minus 4, our A is 8, and our C is 6. Negative 3 squared is 9, and 4 times 8 is 32. 32 times 6 is 192. This is going to give us a negative number. It's going to be negative 183. So there would be no real solutions. Let's do B. B squared is 6 squared minus 4ac. So 5 and C is negative 2. So this is going to be 36 plus 40, which is 76, which is positive, and since it's positive, there will be two real solutions. For C, we have B squared, so 24 squared minus 4, A is 9, C is 16. So 24 squared is 576, did that in my calculator, minus 4 times 9 is 36, times 16 is 576. So that's equal to 0, and since it's equal to 0, there is one real solution. That completes our notes for today. Please write a summary about something that you learned today, so 1 or 2 sentences about what you learned, and then you can work on your homework.